Going to be over properties of real numbers. It is 1.4 in your SS Algebra 1 book and 1A book. The objective is to identify the properties of real numbers. Pretty straightforward on this. This should, for the most part, be a little bit of review because a lot of you guys have been talking about the properties of real numbers really since grade school. A lot of you guys can tell me about the commutative property of addition and all that stuff, and that's what we're doing, but we're going to add on a couple more. And if you look at them, they're pretty much no-brainers because pretty much what properties are rules, aren't they? If I'm talking about a property, I'm really talking about rules. This holds true for everything. Okay, I can do this for literally everything that I do. And again, I'm really big on when it comes to math, I don't care how you do the problem, just as long as you can back it up with why you can do it. Alright, so a couple of vocabulary terms that you guys need to be aware of is an equivalent expression. An equivalent really has the word equal in it, right? It's equal. Equal expression is pretty much what it's saying. It's saying two algebraic expressions that have the same value for all values of the variables. So pretty much what it's saying is the right equals the left. If I said A plus B equals B plus A, that would be two algebraic expressions, because algebraic meaning it has variables and operations. It's an expression because that side is not a complete sentence. That side is not a complete sentence. And the values for all the values of the variables. If I plug in anything for A, okay, and anything for B, and do the exact same numbers, so let's say if I say B equals 2 and A equals 1, sorry for the shakiness of the videos, I really do not know why it is shaking that much. Then I can say 1 plus 2 equals 2 plus 1, which we all know to be true because 1 plus 2 equals 3 and 2 plus 1 equals 3. So that's what it's saying. It's saying if I plug in values for the variables, then I'm going to come up with the exact same number on both sides. That is what an equivalent expression is. The relationships that always hold true for the numbers are called properties. If I look at this, isn't this one of the properties that you guys are very familiar with? What property are you very familiar? What property is this? Good, it's the commutative property. The commutative property tells me that it doesn't matter how I communicate, I'm still going to have the same conversation. Okay? If I was having a conversation with Mr. Marshall, it doesn't matter if he was sitting at his desk and I was sitting at his table, or if we both were sitting at his table. It does not matter. In his office, it does not matter. We're going to still have the same conversation regardless. Okay? It doesn't matter at all. So our communication is still going to be the exact same. Properties of real numbers. Again, a lot of these are very familiar with this. This is now just turning them into algebraic expressions. Now we're getting our grown-up brains on, and we're taking our numbers that we're so used to seeing, and now we're taking it into letters. We're taking it into the whole entire variables. Okay? So, the commutative properties of addition and multiplication, it says changing the order of the addends. And when I say addends, that means something that's being added together. So these guys are classified as addends. That is a term that you should be familiar with. Does not change the sum. So this is telling me that just because I change the order of A and B to B plus A, then I am not going to be changing the sum whatsoever. They're going to be the exact same. And we proved that a little bit we had one thing of numbers. And then it says changing the order of the factors. Now remember, factors are being multiplied, so A and B are factors. So these factors, it doesn't matter if I have A times B or B times A. I'm still going to come up with the exact same thing. Again, that goes back to the commutative property of addition and multiplication. Associative property. Associative property, think about when you associate, you're grouping with people, right? If I associate with my friends, I'm in a group. Associative, it is a group. It says changing the grouping of the addends, and again, addends are something that we add together, so these are addends. Does not change the sum. So notice here, I did not change the order. This is still A plus B plus C equals A plus B plus C. The only thing that changed was the grouping symbols. Associative, get into your mind, groups. Associative means parentheses. I am changing my groups. I am changing what I do first. Okay, because remember, parentheses means I do it first because of PEMDAS. So it is changing what I do first. So it does not change. It does not matter how I add this. I can do A plus B first, or I could do B plus C first. It does not matter. Okay? Then it also says changing the grouping of factors does not change the product. Again, factors are being multiplied. So these guys are factors. So again, it does not matter. Again, the order stays the same. I did not change the order whatsoever. A times B times C, A times B times C. The only thing that did change was the grouping. Because associative, you are grouping. Associative, you're associating with multiple people. You're no longer communicating with just one person. You are communicating with a group. Okay? So if let's say, let's put some numbers in here. So in here we have 23, 9, and 4. Notice how the order did not change. The only thing that changed was the parentheses. Instead of doing 23 plus 9 first, over here you're going to do 9 plus 4. Okay? Same thing over here. If I do 7 times 9 times 10, right here it's saying, hey, I'm doing 7 times 9 first. But over here it's saying 7 times 9 times 10. But I'm doing 9 and 10 first because the grouping tells me I do it first, right? The order does not change, just the parentheses, just what we do first. It's just how we associate first, okay? Why would this come in handy? Well, looking at it up here, 23 plus 9, okay, 23 plus 9 might be a little bit easier to do. I mean, it really depends. The whole entire reason why we do the associative property is to make it easier on us to solve. It depends on who you are too. To me, 23 plus 9 is easy to add. However, some might think it'd be easier to add 9 plus 4 together first. 23 plus 9 is, what, 32? So this is really 32 plus 4. And what's 32 plus 4? 36. Okay. Well, if I look over here, some people may say, hey, 9 plus 4 is 13. That is a lot easier to add to 23. 23 plus 13 is 36. The exact same thing. On this one, I had to actually carry, and I had to do that mentally, because the whole entire part of doing some of these things is to be able to do it mentally, okay? Not that you can't put it into your calculators, but again, you guys know how I feel about that. So, this one would be a little bit easier to do it mentally because I wouldn't have to carry anything. And I can do the exact same thing down here. I would prefer to do the 7 times 9 first because that's 63, right? And then if I take anything times 10, I just put a 0 on it. So it'd be 630. But that's the whole entire part of the properties. Okay, so we also have called the identity. And you guys are familiar with this. You guys probably just never have really called it this before. The identity property of addition tells me that anything I add to 0 is going to give me itself. So you know that because if you do some examples like 1 plus 0 equals what? 1. 8 plus 0 equals 1. Or sorry, equals 8. Wow. Equals 8. Well, can't I say A plus 0? What does that equal? It equals A. It's the identity property of addition because anytime I add a number to 0, I'm going to get itself. So think about it too. It's like when you always carry an ID on you, right? What does that ID show? It shows your identification. It shows you. Okay? It is something that, if you get pulled over, if you guys are, I don't know, speeding. I have some kids who like to speed in high school. Then you have to show them identification. Well, really what you're showing is a picture of yourself. Okay? So you have A plus 0 equals A. Same thing for multiplication, except it's not 0. It's 1. A plus 1 equals A. Or, sorry, A times, wow. A times 1 equals A. Anything I take times 1 is going to give me itself. Examples, 3 times 1 equals 3. 8 times 1 equals 8. So really, these aren't anything that's really new, but at the exact same time, we're giving it names. Okay? Let's see here, a 0 property of multiplication. Again, you know this because you know that anything times 0 is 0. Why do you think 0 is one of my favorite numbers when it comes to graphing? And we're doing functions and all that stuff. It's my favorite number because it's the easiest. Anything times 0 is 0. It's so awesome. It eliminates anything. So there is a property. It is called 0 property of multiplication. Now, some people call these properties a little bit different, but they mean the exact same thing. They might change the wording just a little bit, but I do want you guys to get used to this wording because this is what this series uses. And you'll be seeing this in Algebra 2 and in Geometry. So we also have the multiplication property of -1. And really all that says is, hey, if I take something times -1, I'm going to get its opposite. So if I look at this example, I have -1 times 9. What's -1 times 9? -9. It's all about its opposite. If I take something times -1, I'm going to come up with its opposite. All right, and that includes our going over the properties of real numbers. Now we're going to apply it, all right?